Within a few days, Einstein sent off a letter to his friend Conrad Habicht, imploring him to send a copy of his dissertation and promising 4 new papers in return. The 4th paper is only a rough draft at this point, and is an electrodynamics of moving bodies, which employs a modification of the theory of space and time. The purely kinematic part of this paper, beginning with the new definitions of time synchronization, will surely interest you. 10 years of thought had gone into this problem, from age 16 to age 26. But time synchronization was the final, crowning step in Einstein's development of special relativity. Let's conclude. Einstein and Poincaré, in many ways, share a great deal. They're both physicists, scientists. Poincaré is a mathematician, at a time when they're also very involved with technology, but in different ways. Poincaré, trained at the École Polytechnique and then at the School of Mines, was really concerned with actualized operational procedures in engineering. He really had to investigate coal accidents. He really had to figure out how the telegraphers would exchange signals to map the world and to unify time. Einstein was also deeply involved with technology, but from a different perspective. Einstein was at the patent office, trying to determine if, in principle, this proposed device actually was redundant on some other device that had already been cooked up, or whether it was, in some principled way, novel, an innovation in the long history of technology. Poincaré, the mathematician, was actually more concerned with precision. When Poincaré first discovered that correcting for the synchronization problem of clocks for different observers and different moving frames of reference would be a smaller effect than the errors of an ordinary telegrapher, he dismissed them as not important for physics. When he finally began to see that it could play a role in physics itself around 1900, he limited it to a small correction, a modification of Newtonian physics, but a secondary one compared to the big simplifying structure of classical mechanics. Einstein, once he saw this flaw, once he saw this way in which Newton had things wrong, saw it as the principled starting point for a new vision of the world. He wasn't worried that these effects might be small. He was worried that this changed fundamentally our understanding of the basic starting points of science. In that sense, the two differed, Poincaré and Einstein. Now, these are also two scientists who had immense correspondence. They knew many of the same people. Both of them, for instance, thought enormously highly of Lorentz and cared for him deeply. They met once, as far as we know, at a major conference of the elite physicists of the time, shortly before World War I and shortly before Poincaré's death. At that time, Poincaré was running a session on the nature of light, and Einstein was there to defend and present his work on the idea that light could be particulate, made up of photons as we know them today. And Poincaré was horrified by what he heard from Einstein, because as far as Poincaré was concerned, to hold two contradictory beliefs, light is a wave, light is a particle, was to put all of science into chaos. From a contradiction, Poincaré said anything could follow. Nonetheless, despite this parting of the ways, Poincaré went back after the conference and wrote a recommendation, in fact, for Einstein, for a job that Einstein very much wanted, and explained that if even one of Einstein's rather speculative notions turned out to be true, he would be one of the greatest scientists. Well, more than just one of Einstein's ideas in 1905 turned out to hold good for much of physics. And in that year, as Einstein worked back and forth between philosophy, between physics, between technology, of the patent office, he began to refashion the very way of thinking of a scientific paper. His special relativity paper has practically no footnotes and very trivial mathematics in those early sections where he revolutionizes the idea of space and time. In some ways, it resembles more a patent application than anything else. It's a kind of machine. And in the patent world, you don't footnote a lot. what could be worse than explaining why your invention really derives from all these previous pieces of work? No, Einstein really thought he was building something new, setting out a new science with new foundations, new criticism of notions, and putting the whole in together in a way that would be generative and allow us to understand that Galileo's vision of the world seen symmetrically and constantly in different smoothly running frames of reference held good for all of physics, not just for fish in a bowl in a boat on the Mediterranean. So how do we think about Einstein after all this? And Poincaré, too, in a certain way. You might think of it this way, based on an old medieval saying, when they thought about astronomy above and alchemy below, done in the basement and cooking up new chemicals and looking for transformations in matter. They used to say in the Middle Ages that looking down you see up, because they saw a correspondence between the nature of matter and the nature of the astronomical world, and looking up you see down. Well, here we see something like that. Einstein and Poincaré, by digging deep into technology, whether train coordination or the linking up of longitude finding telegraphers, saw up to the nature of time itself. And looking up to metaphysics in the specificity that both of them demanded, they saw down into technology. Looking down, you see up. Looking up, you see down. And that may be our lasting lesson of our inquiry into Poincaré and Einstein.